Hi, my name is Zongyuan. Today, my teammate Yueran and I will be presenting our 5741 final project on predicting H-1B application status. So what is H-1B? Well, it's a visa that allows US employers to temporarily employ foreign workers. It has two parts: labor condition application, or LCA for short, and H-1B lottery. In this project, we focus only on the LCA stage. Let's take a quick overview of our data. It contains approximately 2.5 million rows and 36 columns. It has mixed data types, and the label of our data is case status. After conducting a preliminary investigation into our data, we've decided to remove some of the redundant features. And then we removed missing values from our data set. In EDA, we took a look at some of the important factors that might influence the outcome of the application. We can see that the wage in most of the applications is between $50,000 to $100,000. And for the plot on the right, we can see that applications from employers in some states are more likely to be certified than others. Most of the applications are being certified. This means that we are dealing with an imbalanced data set. And for the plot on the right, we can see that most of the applications have SOC code starting with 15. This means that most of the applications are computer or software related. Here we can see that top 67 companies submitted around 80% of total applications. And on the right is a list of top 50 companies that submitted the most number of applications. In the next round of data processing, we've hot encoded categorical variables. But since there are many categories in these categorical variables, the transformed data set will have very high dimensions, and the training cost is going to be very high as well. And we might also run into the risk of overfitting. Therefore, we've decided to transform our data set by keeping only 3 digits for NAIC code and SOC code. We've also counted frequency of each company, and then we normalized our wage and transformed data information into duration. As I've said, our data set is very imbalanced. Therefore, using accuracy as a metric is not a good choice. We decide to use average accuracy across different status instead. The average accuracy across different status is defined by the following formula. Speaking of fairness, our features do not contain demographic information such as age, race, and gender. So I think our model is quite fair in that aspect. However, our data set is very imbalanced. If we don't add extra touch to our model, our prediction might favor certified cases more. We've taken the following 2 measures to ensure the fairness of our models. The first one is downsampling, and the second one is using average accuracy as our metric. Next, my teammate Yueran will be discussing the methods and models we've implemented.
Okay, thank you, Zoran. Since we have already mentioned that our data set is very imbalanced, so we are using downsampling to balance the number of samples from different classes in our training data. And the original data set is a 4-class classification. The labels are shown here. And if only certified rate matters, we can turn the model into a binary classification by transforming the certified rate to 0 and the other labels into 1. Here are all the models and the methods we are using in our data, in our project. So when it turns into a binary classification, we are using accuracy on this setting. As we can see in the following table, the decision tree shows high accuracy on this data. You might find some training accuracy is less than the test accuracy. It's because like we use downsample data in SVM, neural network, and logistic regression to balance the data. Let's go back to the multi-class classification. AutoGluon is an auto ML algorithm, which can help us compare performance of different models automatically. We apply autoGluon on the original 4-class classification, and the following table shows the top 9 best models for this dataset. As we can see, lightGBM has the highest score on the test dataset, and lightGBM is a kind of gradient boost decision tree. We then compare lightGBM with models that is not on this leaderboard. The evaluation of all the models we have tried are shown in the table. lightGBM with 1 VSO and multi-class have similar performance. The other models are weaker than the lightGBM. As you can tell from the test average accuracy, it's because lightGBM can handle all the class equally while the others cannot. Now we look into lightGBM with 1 VSO. Here is the top 30 important features generated by the ensemble model. We now further dig into the top 9 features since they have huge gap between the other features. We're going to use artificial data to observe the impact of features on the certified rate, which is to pick some random samples from the test data and fix all the features except the changing features we want to analyze. And we are specifically looking to features with higher importance, which is total wage, prevailing wage, certified rate, course duration, employer previous application counts, and the employment duration. The first is the total wage. As you can see from the figure, if your wage is around average or slightly above average, there will be a slight increase in certified probability. But when it's too large, the certified probability will decrease. The reason for this phenomenon might be that there is some correlation between wage and the other features. And when we adjust the feature manually, it will cause inconsistency to other features. And there might be some special position with very high wage that is easy to be denied in our dataset. Prevailing wage shows similar trend to the total wage. And we can see that the chance to be certified for an individual is highly related to the employer total prior certified rate. So the company's prior certified rate really matters in this application. And also by changing the certified rate, we actually set the denial rate to be 1 minus the certified rate and the other rate to be 0. If you have a very extreme case duration, the probability to be certified is very low. We can use the result to predict the final status. If you're waiting too long, you might be denied. And if it's too fast to get the results, either you're withdrawing your own application or you might be denied. The previous application counts have a very slight impact on the final status. We can conclude that the more application before a higher chance to be certified for an employee. And there is no obvious impact on the certified probability if we are changing the employment duration. There might be some slight decrease when the employment duration is very large. It can be because like the application happens in the very beginning of the employment, always in the beginning of the OPT with longer employment duration, which would cause high denied rate. So our conclusion is that, first of all, the internal process for LCA application is very complicated. Flexible models are more suitable to this data set. For example, the ensemble model that we are using. And the tree-based model work better than the others. And also to increase chance to be certified, the company should offer a very reasonable salary, not extremely high to its employees. And the individual should choose a big company with higher amounts of previous applications or choose a company with higher prior certified probability. Essentially, one should increase his or her own competency to be accepted by a better company to increase their chance to be certified. Next, we have Zongyuan to analyze our model as a weapon of mass destructions.
Thank you, Yaran. So the definition of weapons of mass destruction is that the outcome of a model is not easily measurable, or can give negative consequences or has self-fulfilling feedback loop. So why is our model not a WMD? Well, it has a measurable outcome, which is the status of an application. It does not have a negative consequence because most of the applications are accepted. Our model focused on helping those who might not be approved become aware of their risks. And then it has no prominent self-fulfilling feedback loop because whether an H-1B is going to be approved is determined entirely by the competency of the employee and the industry demand. These two factors are unlikely to be affected by the prediction of the H-1B application status. And lastly, speaking from the demand and supply perspective, the employment is based almost entirely on demand and supply in the labor market. It is unlikely going to be affected by the prediction of our model.
And last, we want to say other results in these slides only represent our subjective suggestions in this project. And that's all. Thank you.
Thank you.